Given, an array intervals where intervals, I, equals, start underscore I, end underscore I, with start underscore I, end underscore I. Rule, delete intervals so that no two remaining intervals overlap. Touching only at an endpoint is allowed, 1, 2, and 2, 3, do not overlap. Return, the minimum number of intervals you must remove. Example 1, intervals 1, 2, 2, 3, 3, 4, and 1, 3 on a timeline. The first three chain end to start without crossing interiors. The wide interval from 1 to 3 swallows part of that chain, so it collides with more than one neighbor. Removing only that wide interval leaves 3 safe intervals, so the answer is 1. Example 2, 3 copies of 1, 2 all sit on the same slice of the line, so each pair shares time in the middle. Keep one and delete the other 2, so the answer is 2. A left-to-right greedy needs a scan order. Gold ticks on the axis mark each interval's end, that is when busy time can step forward. So stack rows by increasing end, if 2 share an end, break ties by start so overlaps have a fixed order. One timeline, one room, overlaps force removals. Sort by end, tie break by start, that is the scan order for one greedy pass. Yellow bar marks room free time. We slide it right as we keep intervals. First row 1, 2, keep it. Room is free from 2 onward. 2, 3 clears the bar, keep it, and slide the yellow line slowly to 3. 1, 4 starts before 3, overlap. Skip it and count 1 removal. 3, 4 starts at 3, keep it, and slide the line to 4. That completes this greedy pass on the end sorted order. Survivors are exactly the rows that pass that test in sorted order. Same 3 intervals, 1 long block and 2 short ones. If we scan by start time, the wide interval comes first. Keeping it blocks both shorts, so we need 2 removals. Sorting by end lets the shorts clear first, 1 removal is enough. For overlapping intervals, sort, then 1 greedy scan left to right. Sort key, smaller end first, ties by smaller start. First row 1, 2, keep it, running end becomes 2, removals stay 0. Two, 3, start meets 2, so keep, slide end to 3. One, 4, start is before 3, overlap, increment removals. Three, 4, start meets 3, keep, end moves to 4. Return removals, 1. N is the number of intervals. Time is O of n log n worst case, sorting by n then start, plus 1 linear scan over n rows. Space is O of 1 extra during that scan, only previous end and a removal counter besides the sorted list. Function, input is a list of intervals, output is how many to remove. Sort every interval by end time, then by start when ends tie. Store the first interval's end as the last accepted finish time. Initialize the removal count to 0. Loop over all intervals after the first in sorted order. If this start is still before the last finish, we have an overlap. Increment removals and leave the finish time unchanged. Else, we keep this interval. Set the running finish to this interval's end. Return the removal count.